Alrighty, welcome back. Well, me. But we're going to go ahead and talk about simplifying the expression. Write your answers using positive exponents. So we take a look at number 32. I see that everything is, this whole quantity here is raised to the negative third power. And without having to do the work, I can just say that since I'm going to, give everyone the money, give everyone that negative exponent, they're going to go on the other side of the fraction. Without having to show that work, I can just say that this is going to be 2, and then since I move it to the other side of the fraction, I have to make that exponent positive. So I have, 2/3, and then a cubed raised to the third power, and then b to the fifth power raised to the third power, okay? 2 to the third power, don't make this mistake, it's not 2 times 3, it's 2 to the third power. 2 to the third power is 8, and then this is where people should use their formula chart. A cubed raised to the third power, a cubed raised to the third power is a to the ninth power. Power to a power, you multiply those exponents, so you have a to the ninth power here. And then b to the fifth power raised to the third power, power to a power, you multiply. So b to the 15th power, this is my answer. Next I want to go ahead and do, and since I don't have a negative exponent, I can just go ahead and distribute, give everyone the money. So I have 2 to the fourth power times a squared to the fourth power times b to the fifth power raised to the fourth power, and then c raised to the fourth power. And let me just give myself some more room. I have this 2 floating up there, and I got to distribute, give everyone that money. So -3 squared and a to the second power times b to the third power squared. Actually, that should be, let me make a change there, a squared. And then now I'm left with c squared raised to the second power. All right, let's go ahead and just simplify. 2 to the fourth power is just 16. A squared to the fourth power is a to the eighth power. B to the fifth power raised to the fourth power is b 20. And c to the fourth power is just c to the fourth power. -3 squared is just 9, so I'll put a 9 there. And then a squared, b to the sixth power, c to the fourth power. And am I done? No. So now I need to figure out, I got to go and combine bases. 9 to the 16th power is just 144. A to the 8th power times a squared is a to the 10th power. B to the 20th power times b to the 6th power is b 26. C to the 4th power times c to the 8th power, that is just c to the 8th power. And this should be my answer here. Okay. 34, evaluate the expression. So I'm going to go ahead and I see some negative exponents here, so I'm just going to create a new, fraction bar. That's pretty ugly, so let's try again. So 2 to the second power, that's positive, but I don't need to do anything, so I'm just going to leave it as 2 to the fourth power here. I have this x to the negative third power, and that's just going to go down below, and I'm going to make that exponent positive. Y to the negative second power, that's a negative exponent, so it goes to the other side of the fraction. Z to the negative first power, it's a negative exponent, so it goes to the other side of the fraction too. And then 8 to the negative first power, yes, that also goes to the other side of the fraction. I'm dealing with the stuff on the bottom now, so 8 to the first power. And then x to the negative sixth power, it's in the bottom, and it's a negative exponent, so it goes up to the other side. Y to the 0 power, that's just 1, so I cancel that out. And then lastly, I'm left with z to the 6th power. I'm going to go ahead and simplify. 2 to the 4th power times 8 to the 1st power. So we know that 2 to the 4th power is just 16. 16 times 8 is 128. And I'm left with x to the 6th power times z to the 6th power divided by x squared, y squared, z to the 1st power. Okay, and now I'm going to go ahead and divide like exponents. If I have the same base and I'm dividing, you got some exponents, you go ahead and subtract those fractions. So, x to the 6th power divided by x squared, that's just the same thing as x to the 6th power minus 2. So I'm left with 128 x to the 4th power. And then the z to the 6th power divided by z. That's the same thing as z to the 6th power minus 1, which is just z to the 5th power, and all over y squared. All over y squared. This is my answer. Okay? Hopefully that, you know, you remember that stuff there. That's totally fine. Okay, find the sum or difference. Finding the sum or difference. Okay, so on the test, a lot of people went ahead and just added, you know, do 2x squared plus 3x squared, and that's 5x squared. But people are neglecting this negative in front, because if there is a negative in front, you got to go ahead and distribute to every term. So you have, you know, 2x squared plus 5x minus 3x squared. Actually, I'm going to go ahead and do that without the parenthesis. Minus 3x squared minus 27. And then you're going to go ahead and combine the like terms. You have to make sure that you can add those. You can add only if you have the same base and the same exponent or the same degree. Because notice here, I can add the 2x squared and the negative 3x squared because they have the same base and they have the same exponent. And we're only adding. And since we're adding or subtracting, the exponents don't change at all. Right, like we did at the beginning, 5x plus 2x. Do I say that's 7x squared? No, I say that it's just 5x. Here in this case, since we are moving on to the new in the second semester, we're going to go ahead and combine the like terms. So what is 2x squared minus 3x? What is 2 minus 3? That's going to be negative 1 or negative x squared. And then what am I left with? I am left with, I don't know why I have an x here, so I'm going to get rid of that. So positive 5 minus 27, that's just going to be minus 22. This is my answer. Okay? So if you didn't see that, I'm going to go ahead and just highlight. This is what we added. That's my result. And this is my thing. There you go. Don't forget to distribute the negative. Don't forget to distribute the negative when it says find the sum or difference. Okay? What is the degree of the polynomial? The degree of the polynomial is the highest exponent from the expression. So we look at these terms here. The highest exponent that I see here is 4. So that means the degree of this expression is 4. But what is the leading coefficient above? Remember, the leading coefficient is the number in front of the variable, with the highest exponent. Okay, so put that down there, and we see that, okay, this is my highest degree. So what is my, leading coefficient? My leading coefficient is that number, which is this invisible 1. So my leading coefficient is just 1. Okay, hopefully you're remembering this. Okay, simplify, 2x plus 5, the quantity squared. Now, again, I told you, do not make this mistake. Don't, give everyone the money, because this stuff is not multiplication. You can't distribute that square. What you have to do is you're going to have to write 2x plus 5 squared, or 2x plus 5 twice, like this. And then I'm going to go ahead and just FOIL. So I do 2x times 2x. That's 4x squared. And then I do 2x times 5. That's positive 10x. Plus 5 times 2x. That's plus 10x. And then 5 times 5 is 25. Am I done? No, I need a CLT at this point. This is my answer. Okay? Alrighty, so now we're going to get in the territory of, first semester business here. What is the equation in slope-intercept form of the line that passes through the points 2, negative 2 and is perpendicular to the line represented by y equals 2 to the fifth power, 2 over 5x plus 2. So let's just draw a graph and just, think about what the question is asking. They're saying that I'm already given an equation with a slope. Okay, let's say this is y is equal to 2/5 x plus 2. It's not exact. I'm sorry if it's not exact. There. And what I'm trying to do is I'm trying to find the perpendicular line. So like something like this, okay? And it creates that 90-degree angle. So they give me this, but I'm trying to figure out what this is. That's my job. And it says it's perpendicular. And when I say perpendicular, I'm saying, you know, negative inverse, meaning, you know, opposite sign, flip the fraction. So I use this information, but I don't care about this 2. This 2 is irrelevant. So my, you know, perpendicular slope, since this is 2 over 5, I got to flip the fraction and make that negative. Since this is a positive, I got to make this negative now. And then I write, let's see, I'm going to go ahead and get rid of this. I think y'all understand now. If not, just replay the video. Okay, we got y equals mx plus b, because this is the equation on the line. And I write y equals negative 5 over 2x plus b. Okay, now I'm trying to figure out what this b is, but I'm already given a point. This is my x and this is my y. So this is my point. I'm going to go ahead and use this information. This is relevant. This 2 is not. Don't include this 2 at all. This should not be anywhere in your problem or when you're doing your work at all. You use this and you use this, and you use whatever it asks you. If it asks you for parallel, you use the same slope. If it asks for perpendicular, you use opposite sign, flip fraction. Okay, so let's go ahead and plug things in. We see that there's my y value is negative 2, so this is going to be negative 2. Let's write negative 2, which is equal to negative 5 over 2 times what? Well, that's just x, right? Or sorry, 2, because 2 is my x, plus b. Okay, so then what can I cross out? I can cross out this, because negative 5 times 2 is negative 10, and negative 10 divided by 2 is just this number. So my shortcut is just cancel this out. So then I'm left with negative 2, which is equal to negative 5, plus b. I'm going to add both sides by 5. So I'm left with 3 is equal to b. Okay, so since b is equal to 3, I'm going to use this information and then use this, basically use this information, replace b with that value. And that's going to complete the equation that I need, because that equation is going to be perpendicular to the line that was given to me from the problem. Okay, so we write y equals negative 5 over 2x plus 3. That's my answer. Which equation is the same as 2x minus 5y is equal to 15? Well, let's take a look at, what do they all have in common? It seems like everything is in the form y is equal, so that means I have to solve for y by itself. So I have 2x minus 5y, which is equal to 15, and I'm trying to solve for this variable here, right? Now, what I have to do is I need to get this by itself. That's negative 5y by itself. So what is in the way? I need to subtract both sides by minus 2x, both sides, and I'm left with, negative 5 is y is equal to negative 2x plus 15, and I'm going to go ahead, since now this is by itself, I can go ahead and get rid of this negative 5, right? Negative 5 times y, what is the opposite of multiplication? Well, it's just division, right? You got to go and divide both sides by negative 5. Everything gets divided by negative 5, okay? So I have y is equal to 2 over 5x plus or minus 3. And this is what I'm trying to look for when I'm looking at the multiple choice answers, and it seems like A satisfies that. Okay, now we're going to apply geometry. No, not apply geometry. We're going to apply our power rules into a, geometrical context, I guess you could say. So what I want to do is a rectangular prism has a width of x inches, a length of x squared times y inches, and a height of y cubed inches. Which expression represents the volume in cubed inches of this rectangular prism? And the formula for finding the height of a rectangular prism is length times width times height. So that's going to be very, very useful when I'm doing this problem. So we know that it's, you know, the volume of a rectangular prism is length times width times height. We know that the length is x squared times y, the width is x inches, and then the height is just y cubed. And all I'm doing right now is I'm just multiplying, right? So I'm gonna replace my variable. So I have x squared times y times x times y cubed, and then I'm gonna go ahead and multiply like exponents like base, or sorry, multiply like bases. So x squared times x is going to be x cubed, and then y times y cubed is just y to the 4th power. Okay, hopefully y'all can see that. And now we're going to go ahead and move on to number 41. It says a concession stand is selling hot dogs and sodas. Each hot dog costs $1.50 and each soda costs 50 cents. The total amount of money the concession stand made today is $78.50. They sold a total of 87 hot dogs and sodas combined. Find the number of hot dogs sold and the number of sodas today. So this right here, remember, this is what you call a system of equations. The first thing I want to do is whenever I have, when I'm dealing with word problems, I like to define a lot of things. And how do I set up my equation? Let's say that x represents, so it says each hot dog. So I like that. When I see each hot dog, I say x amount of hot dogs because I don't know how many hot dogs are being sold. And then I see, you know, my other key word here is each soda. I don't know how many sodas I'm dealing with, so I'm going to say that y represents soda. So x represents the hot dogs and y represents the sodas. And how am I going to set up this equation? It says each hot dog costs $1.50 and each soda costs 50 cents. So remember, that's just saying money plus money is equal to the total amount of money. And then what else do I have? The total amount of money the concession stand made today is $78.50. That's relevant, right? That's going to say, well, I have, so each hot dog is $1.50 each, so $1.50 times x plus 50 cents times y is going to give me $78.50. How many hot dogs do I have or how many hot dogs and sodas do I have in total? So I write hot dogs plus sodas is equal to, you know, total amount of hot dogs and sodas there. Okay, so this is how I'm going to set up my equation. Money plus money is equal to the total amount of money. And I said each, right? So this is going to be $1.50x plus 0.50y is equal to how much money? $78.50. That's my total. And then I don't even know, I said x is equal to hot dogs, y is equal to sodas. I don't know how many hot dogs and sodas are sold. I don't know how many hot dogs are there or how many sodas are there that are being sold, but I know that the total is 87. So I write x plus y is equal to 87. Okay. So we need to figure out the number of hot dogs sold and the number of sodas sold that day. So I'm going to go ahead and just erase this. I'm going to go ahead and erase this. I need more room because now I'm going to, you know, use elimination or substitution to figure out what to do. What do I want to get rid of? I probably want to multiply, or I want to go ahead and get rid of this x, because it doesn't matter what you want to get rid of. Whatever looks easy, but I don't know which one looks easy. It kind of looks the same to me. So I'm going to multiply everything by negative 1.50x, and, oh, not 150x, that's going to be negative 1.50. And once I FOIL, I'm going to be left with negative 1.50x minus 1.50y, which is equal to, well, what's 87 times negative 1.50? I have no idea. That's negative, sorry, let me see. Is that right? Negative 1.50? Negative 130.5? That doesn't look right to me. Hold up. Let me use my calculator again. So, let's see. 87 times negative 1.50 is negative 130.5. Okay, never mind. I'm losing it. Okay. So now that I have that, I can say goodbye to this. And now I have that, I can go ahead and eliminate this, right? Because now we're going to add, vertically. So 0.50y plus negative 1.50y, that's just going to be negative 1y, and then 78.50 plus negative 130.5, that is negative 52. And then looking at that, that's just going to be y is equal to 52. So y is equal to 52, I need to go and figure out what my x is. What is my x, right? I don't know what that is. So what I'm going to do is I use this given information that I found and use one of my equations, solve for x, and then I'm good to go. So let's use this equation here. So I have 1.50 x plus 0.50 times 52 is equal to 78.50. And 0.50 times 52, that's just saying 52 divided by 2, right? That's the same thing. So that's 104. So I'm left with 1.5x plus 104 is equal to 78.50. What did I do wrong here? That's not right. That's not. No. 52 divided by 2 is 26. There you go. And then I'm going to subtract both sides by 26. So you're left with 78.50 minus 26. And then you divide both sides. So 1.5x is equal to 52.5. Divide both sides by 1.50. So you're left with 35. X is equal to 35. So that means the number of hot dogs sold at 35 and the number of sodas sold is 52. Can we see 32 plus 52 is that 70 or 87? Oops, 35. Yep, that's 87. Yep, that's correct. There you go. So basically, systems of equations is just finding the unknown. If you're given information, how do we know? How can we determine how many things are being, what's this value and what's that value? That's basically systems of equations. Okay, substitution. Use substitution to solve the system of equations below. Substitution is another way of saying replace. And I look at these two equations and I see that y is equal to something, and here's x plus y. Notice that if y is equal to 2x plus 5, then this right here is also 2x plus 5. Right? That's logical. So if I write this, I have x plus 2x plus 5, which is equal to 2. I'm going to go ahead and combine the like terms. So now I'm left with what? So I subtract both sides by minus 5. And I'm left with 3x is equal to negative 3. X is equal to negative 1, but I don't know what y is equal to. So this is pretty handy because I can just say y is equal to 2 times what? Well, I know that x is equal to negative 1, so I replace that x with negative 1 and do plus 5. 2 times negative 1 is going to be negative 2 plus 5. Negative 2 plus 5, that's just going to be 3. So that means in the form x comma y, it's negative 1 comma 3. Okay? So now, 43, it says use elimination to solve the system of equations below. I'm going to go ahead and eliminate. What's the easiest thing that I can eliminate? This y, these y's, right? These can go away. So now what am I left with? Well, 2x plus x is 3x, and then 5 plus 1 is just 6. So x is equal to 2, and since I know x is equal to 2, I can use this equation or this equation to figure out my other variable or value, which is y. So let's use the second one. So I have 2 minus y is equal to 1, and I'm going to subtract both sides by -2. So I'm having negative y is equal to -1, y is equal to 1. So you have this form right here. This is the answer. Evaluate when f of x is equal to x squared minus 18x plus 2. Remember, evaluating is saying I got to replace my x values, replace x with -4. Okay, that's basically what it says. When it says evaluate, when you're given something, all you got to do is replace. So we know that here's my x, here's my x, here's my x, and I'm replacing those those variables with -4. So I have -4. Remember those parentheses, because -4 squared is not -16. If you put it in your calculator with those parentheses, it's going to give you 16 minus 18 times -4 and then plus 2. -4 squared, -4 quantity squared, that's going to be 16 minus, okay, what's 18 times 4? -18 times -4, right? That is going to be 72. And then I put plus 2, and then I'm going to go ahead and add everything. 16 minus 72 plus 2, that's just -54. This is my answer, and I am done with this review.